Okay, today we're going to take a look at right triangle trigonometry and really run you through a quick crash course and how to work through all of those problems that we have with right triangle trigonometry. This is going to be a unit that we're going to do after the end of course test. So we're going to try to get you as much information as you can to try to pick it up. The big thing that we have is when you have right triangle trigonometry, the first key piece is it has to be a right triangle. Okay, if we don't have a right triangle, okay, this rest of this stuff does not matter. Okay, the other big key piece is these trig ratios. Now, the one positive that you do have is the trig ratios that you see here, sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent, are on your end of course formula sheet. Okay, you can see this is actually a screen grab of what that looks like. Okay, so you're going to have the sine of angle A being the opposite side over the hypotenuse, the cosine of angle A being the adjacent over the hypotenuse, and the tangent of A being the opposite over the adjacent. So if we have a right triangle and angle A being here, our hypotenuse, remember, is the side across from the right angle. Okay, so the other two pieces that you need to know and recognize are the opposite and the adjacent. Okay, so the hypotenuse is your biggest number. It's across from the right angle. If I draw a line from A, the side that I hit will be my opposite. And then the remaining leg that's not the opposite is the adjacent side. Now, some of the release test questions that we've seen through this have been as simple as writing sine, cosine, and tangent and putting the numbers down. Some of them have been solving triangle pieces with that. We're going to show you how to do each of those pieces. Okay, so we're going to find each indicated ratio. We're going to express our answer to the nearest, in this case it says 10,000th. We're going to do it as fractional pieces. The first thing that we have to recognize is which side is our hypotenuse, and that's number 13. The 13. It's always your hypotenuse is the biggest number. If they're going to ask you to find the missing sides, they're going to give you the hypotenuse. Now, for angle A, which is what we're starting with, my opposite side is the one that I would hit if I draw the line across from it. So when I list the sine of A, remember the sine is the opposite over hypotenuse. So my opposite side is 5, my hypotenuse is 13. Okay. Now, when we get into this and have full time, we will talk about the sine being so. The sine is the opposite over the hypotenuse. Our cosine, okay, the C is equal to the adjacent over the hypotenuse. So we'll call it so ca, and we're going to finish with a tangent, which is the opposite over the adjacent. So we're going to refer to it as SOHCAHTOA as our acronym that we will use to remember how our ratios go. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so the cosine of A. If this is my opposite and this is my hypotenuse, this is my adjacent side. So the cosine is the adjacent side, which is 12, over our hypotenuse, which is 13. And then finally, the tangent, the TOA piece, opposite over adjacent. My opposite side is 5. My adjacent is 12. Now, there is another trick to this as well. When I go to flip my ratios, okay, and I'm going to go to green. When I look at angle B, my opposite side now becomes 12, and my adjacent side in the green piece becomes 5. Okay, so when I go to do my sine of B, my opposite side now is 12, and my hypotenuse is 13. And for my cosine of B, my adjacent side is 5, and my hypotenuse is 13. So what we've done, if you take a look here, is notice that the sine of A and the cosine of B are both the same. And the cosine of A and the sine of B are both the same. And because you're switching your opposite and your adjacent, the tangent of B will be 12 over 5. Okay, take a second to write that all down. Okay, you can pause the video to do so. Okay, so we come to the next side. We're still looking at SOHCAHTOA. Okay, I'm going to go blue on this first part. My hypotenuse is 15. Okay, again, we're going to start with angle A. So my opposite side is 9. And my adjacent side then is the remaining piece, which is 12. So when I go to do sine as opposite over hypotenuse, my opposite side is 9. My hypotenuse is 15. For my cosine, I'm using the adjacent side, which is 12, over the hypotenuse, which is 15. And for the tangent, it's OA, so opposite over adjacent. And my opposite side is 12, or 9. My adjacent side is 12. Now, when we go to flip, remember that when you flip to go to angle B, my opposites and adjacents are going to switch. You can also just switch my cosine of A with the sine of B. So this is 12 over 15. My cosine of B then is 9 over 15. And my tangent, you're going to take the reciprocal, which means to flip the fraction. Once you have those ideas down and you can remember that the sine of A is equal to the cosine of B, that is a key piece of what they're going to want you to know for the end of course test. The sine of A and the cosine of B are going to be the same. Similarly, the cosine of A will equal the sine of B. And you'll see that later on as well. Okay. Our next example that we have asks us to find the sine, cosine, and tangent of the indicated angle. So the sine of A. Okay, my opposite of A is this side over here, which is 20. Okay, my hypotenuse is the biggest number. That's 29. That's not going to change even when I change my side lengths or my angles. The cosine of A then is the adjacent side. My opposite's down below. My adjacent side is my remaining leg. Remember, the legs make up the right angle. So that's 21 over 29. Then our tangent of A is opposite over adjacent. My opposite over my adjacent is 20 over 21. Okay, so now we're going to go look at B. Okay, and when we look at angle B, my opposite side now becomes 21. And my adjacent side now becomes 20. So when I go to do the sine of B, remember that's equal to the cosine of A. These two things are the same. So I can just go with 21 over 29. Similarly, my sine of A is going to equal my cosine of B. And I can just use 20 over 29. And finally, the tangent of B will be 21 over 20. Now, the other thing that you need to know, sine and cosine. Okay, the number on top must be smaller than the bottom. In other words, your numerator has to be smaller than the denominator on sine and cosine. Okay, tangent does not matter. Your tangent can be greater than 1, but that is the only trig ratio that can be bigger than 1. The sine and cosine, our numerator always has to be smaller than our denominator. Okay. Now, how are we going to take a look at this and use this out into other things? We've not seen a lot of release test questions with this, but when solving a right triangle, you want to find the angle that you're given on what side you know. It could be the opposite, the adjacent, or the hypotenuse. But you have to be given one acute angle and one of the sides. Once you know the side, look to SOHCAHTOA in order to figure out what trig ratios to use. For example, if I know the opposite side, okay, and I look at SOHCAHTOA, the opposite's here in the sine and in the tangent. So I'm going to write my equation as the sine of whatever my angle is equals the opposite over the hypotenuse, and the tangent is the opposite over adjacent. But I want to use the two ratios where the opposite shows up because that's the side I know. If I know the adjacent side, I'm going to use the cosine and tangent. If I know the hypotenuse, I'm going to use the sine and the cosine. And then we're going to solve the equations for the variables. The key is where your variable is. If the variable's on the bottom of the fraction, divide the numerator by the trig ratio. The variable's on top, multiply the trig ratio by the denominator, and that will give you the answer. Now that sounds really complicated. It's really not as bad as it sounds. Okay, in this picture, I am given the hypotenuse and my 41-degree angle. Okay, so when I look at SOHCAHTOA, I look to see which trig ratios use the hypotenuse. And you can see it's in SO and CA. So I'm taking the sine of 41 degrees. I'm going to do the tangent of 41 degrees. Okay, once you have identified which two trig ratios you're going to use, the rest of this becomes just writing the equations like we did before. So I'm looking at the sine, and what's opposite of 41 degrees? Okay, so my opposite side here is x, and my hypotenuse is 73. That's not anything different that you've done so far. Now, with the tangent of 41, okay, the tangent is opposite, or I'm sorry, I want to use the cosine of 41 because I know the hypotenuse. It's my fault. Okay, so the cosine of 41 is going to be the adjacent side, which is y, over my hypotenuse, which is 73. Now, one thing that you do have to make sure of is that your calculator's in degree mode. Okay, and most of the time with the calculators, with the TI-30s especially, they're going to default to degree mode. If you are using the TI-84s, you need to click on one of the buttons in order to make sure it should be, I think, in the mode button where you're trying to get down. It'll be like the third or fourth line down. It'll say radian or degree, and you need to make sure degree is highlighted or it will mess everything up. Now, so if you come up with answers that are not correct and you're kind of puzzled as to why, see me when we get back to class the next day and I'll take care of that. Okay, it's just a simple move on your calculator. But you need to know how to do it because you'll see that on the end of course test. All right, so my number here is on the bottom. Since this number is on the bottom, algebraically, to get rid of my fraction, I'm going to multiply. So I'm going to take 73 times the sine of 41, and that's going to give me x. And when I take 73 times the sine of 41, I get 47.89 for x. Okay, now over here, my cosine, the number's on the bottom again, so I'm going to multiply also 73 times the cosine of 41 to find the value for y. And 73 times the cosine of 41 is 55.09. And that's the length for y. The big difference here now is that we're solving the equation. All right. The next example we have, you guys again can pause the presentation if you need to kind of keep caught up on the notes, is to find the value of each variable. Okay, so the angle that we know in this case is the 32-degree angle. So I'm going to write SOHCAHTOA up at the top of my paper, and you might want to do this on your scratch papers just to kind of give you that idea of what trig ratios go where, but you've got it on your formula sheet too. Okay, so it's not like it's a mandatory thing. All right, so for 32, okay, I don't know my opposite. That's x. My hypotenuse is y, so I know the adjacent side. So I look at SOHCAHTOA, adjacents and the tangent and the cosine. So I'm going to write down the cosine of 32. I'm going to write down the tangent of 32. And we're going to list those variables. For the cosine, I'm taking the adjacent over the hypotenuse. My adjacent side is 8. My hypotenuse is y. And for the tangent of 32, tangent is opposite over adjacent. So my opposite side is x. My adjacent side is 8. Now, the tangent key we're going to do first because that's just like the problem we just finished. Our numbers here on the bottom. So I'm going to multiply both sides by 8. And that's going to give me x on this side, because the 8s would cancel out, and 8 times the tangent of 32 on the other. So when I take 8 times the tangent of 32 on my calculator, I'm going to get 4.99, which actually is going to simplify all the way out to 5. And you can type that directly into the calculator exactly as you see it, 8 tan 32, and it will give you the answer. Your sine, cosine, and tangents should be one row above the 7, 8, 9. On the other side, algebraically, we can go through a big mess of this, but the final answer needs to be, since my number's up here on top, I'm going to divide by my trig ratio. So you're going to take 8 divided by the cosine of 32 on your calculator. Type it in just like that, 8 divided by cosine 32. The calculator will give you your answer right back, and in this case, that comes out to be 9.43 for y. Okay, we're going to do one more where we're solving for x and y. And this time we're going to go with the opposite side. The numbers are actually going to come out exactly the same as the problem before. Okay, I know the 32-degree angle right here. This is my opposite side. This is my hypotenuse. This is my adjacent. Okay, so again, we write SOHCAHTOA at the top. Okay, now, with SOHCAHTOA, I know the opposite. So my opposite is here in the sine and the tangent. So I'm going to write the sine of 32 and the tangent of 32. I'm going to switch colors here, make it a little bit easier to see. All right, so the sine of 32. Sine is opposite over hypotenuse. My opposite's 5. My hypotenuse is y. And then for the tangent of 32, tangent's opposite over adjacent. My opposite's 5. My adjacent is x. This time both of our numbers are on top. And that means that we're going to divide by the trig ratio. So I'm going to take 5 divided by the sine of 32 on my calculator, and that will give me my value for y. Okay, that's going to give me 9.44. Okay, on the other side, my x is on the bottom. So x is going to equal 5 divided by the tangent of 32. Again, this is going to be done primarily on the calculator, and my value for x in this case is going to come out to be 8. Okay, the calculator usage is going to be something that we probably need to double check again in the next class just to make sure that we're good to go. Okay, other things that you might see. Okay, other trig notes. Cosine of x is equal to sine of 90 minus x. Okay, and then in the right triangle, cosine of a is equal to sine of b, and the tangent of a is equal to reciprocal tangent of b. We've already talked about this. What we're talking about up here with this piece, we're going to bring this down, is that the cosine of 60 is equal to the sine of 30. Okay, the sine of 50 will be equal to the cosine of 40. They are always going to be equal. The two numbers here and here have to add up to 90. That's where the 90 minus x comes in. The cosine of 20 will equal the sine of 70. The sine of 5 will equal the cosine of 85. Okay, that's exactly what we're talking about with that. We've seen some of these test questions with those. Okay, so just make sure that you're aware of how to take care of that. Felicia wants to draw a triangle PQR such that the conditions shown are true. The area is not 6 units and the cosine of P is 0.6. Okay, so when we think about our cosine, remember that our cosine is equal to the adjacent side over the hypotenuse. Now what's going to make this be the easiest piece is we're going to let P be some point. Okay, so there's P. My adjacent side is 6/10, so what that means is to make something like this. Okay, so I'm going to go out 6 units. 1, 2, 3, 4, 5, 6. So this should be my triangle. Okay. So this is my adjacent. Now, I have to get my other side of my triangle to be 10. So 6 squared plus x squared will equal 10 squared. Okay. Remember that all these problems are Pythagorean theorem problems because it's a right triangle. So to find out what our other side of x has to be, we take 100 minus 36, so that x squared is 64, and that means that our value for x is 8. So then I'm going to count up 8 blocks. There's going to be Q, we'll call point R up here, and that's going to make my hypotenuse be 10. Now the other part to this, remember, was we wanted to make sure that our triangle did not have an area of 6 square units. And if we take 6 times 8 and divide it by 2, we're going to get 24. So we're perfectly fine with that. That was actually on the original practice test that the state gave out with the end of course test. We have not seen anything be released like that except for the very first year, and that was before the test had ever even been given. Okay, so I would not be overly worried about that. Okay, an equation is shown where theta is less than x, which is less than 90, and 0 is less than y, which is less than 90. Create an expression for x in terms of y. Remember that our value for x is always going to be found by taking 90 minus y. Okay, this kind of ties in with that problem that we did back a couple slides where we said the cosine of 70 was equal to the sine of 20. Okay, angle A is the complement of angle B. What equation about the two angles have to be true? Remember that the letters have to be opposite with opposite signs. The sine of A cannot equal the sine of B very often. Okay, the sine of A and the cosine of A won't ever be the same. Our correct answer is down here. The cosine of A will always equal the sine of B. Okay, so with the acute angles, the cosine of one will be the sine of the other. Now, some problems will include angle of elevation and angle of depression. These are not sad problems by any stretch of the imagination. If you look at the picture, you should realize that these are alternate interior angles and as a result are going to be congruent to each other. When I do the problems like this, I always draw my pictures of angle of elevation, knowing that the two triangles are congruent. Basically what's happening is somebody's standing here in a tree looking up at the airplane, that's the angle of elevation. But if the pilot's looking down at the tree, that's the angle of depression. Okay, those two things are always going to be alternate interior angled. So when I look at a problem like this, a ramp is built with an angle of 25 degrees. This is going to be the 25 degrees here. I always look at that as my angle of elevation. I want to find the length of the inclined surface. So again, the problem that we're looking at here is SOHCAHTOA. Okay, what do we know? Okay, I know the opposite side from my angle, and I'm looking for the hypotenuse. So we look at SOHCAHTOA, I'm using the sine. And because I'm only looking for the length of the ramp, I don't have to worry about doing both parts. I don't have to worry about the sine. So the sine of 25 is equal to 15 over x. Now, because our number is on top, what we're going to do is divide by the trig ratio. So when we go to solve this on our calculator, we're going to take 15 divided by the sine of 25. And that will give us our value for x. And that should give us a ramp of 35.5 feet. We round to the nearest tenth. Okay. This is where some of the extra paper can come in handy, is to kind of sketch the pictures, because you may not always have pictures. An airplane takes off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? Assume that the airplane flies in a straight line and the angle of elevation remains constant until the plane flies over the building. Now we get into a problem like this and we have to use an inverse trig ratio. Okay, so my airplane is taking off 200 yards in front of a 60-foot building. So my building is 60 feet tall and I'm 200 yards away. Now, one thing that we have to keep in mind here is I'm looking at yards and I'm looking over here at feet. I can convert either direction. For example, this 60-foot building divided by 3 is 20 yards. So my angle of elevation that I'm creating here now is going to be found by looking at the opposite side over here and the adjacent side. So I'm going to use opposite and adjacent. If you look at SOHCAHTOA, opposite and adjacent is the tangent. So my tangent of x is equal to 20 over 200. Now, I'm going to see now that x is on the side with my angle. When I do that, I'm going to use the inverse ratio. And that inverse ratio is found by taking second tangent. Okay, so on my calculator, I'm going to hit the yellow second key first, and then the tangent, and then I'm going to put in 20 divided by 200. Okay, so it's going to be second, the tangent key, and then that's going to bring up the parenthesis. Take 20 divided by 200 and close your parenthesis. And that gives us 5.71, and since it's got more numbers there, because we sure don't want to crash into the building, we're going to round that up. Okay, so I need my thing to be at 5.72 degrees, or else I'm hitting the building, because it's 5.71 and change. Don't round down. okay, if you're taking off. Okay, so it has to be a 5.72 degree takeoff. Okay. When looking for the angle, you need to use the inverse trig ratios. Okay, these are found on your calculator by hitting the second button, and then in this case the sine. Okay, so for example, the sine of 3/4, we hit second, sine, and then 3 divided by 4. Okay, so it will look like this on your calculator. Second, hit the sine key, you get the fraction to come up. Good. Now, what that's going to actually look like is this. Sine -1. Okay, and that's going to give us 48.59 degrees. Okay. Here are a couple other ones. Okay, the sine of A is 0.25, so if you have that, again, just hit second sine, 0.25. That's going to give us 14.48. And our final one is the cosine of A. So we hit second cosine of 0.38. And that's going to give us 67.66. Again, if you guys have problems with this as you're going through these, make sure you try them out because we can go through that on the calculator a little bit more in class during our next class period. Okay, the final question then is to find each measure to the nearest tenth. Okay, when we're looking at this problem, we need to find QR, the measure of angle Q, and the measure of angle R. Okay, when we take a look at this, the measure of angle Q has this side over here, so this is my opposite. And then my adjacent side then is going to be the remaining leg. So because I'm using opposite and adjacent, we're going to look at SOHCAHTOA and try to come up with our answer on this one. Okay, my opposite side is 3, and my tangent is 5. So the tangent of Q is going to be 3/5. Okay, so we're going to hit the second tangent key on our calculator. So second tangent of 3/5 is going to give us 30.96 degrees. Okay, so that's the measure of angle Q. Now, we also then are going to need to find a measure of angle R. And with R, remember the only thing that's going to happen is our opposite and our adjacent are going to switch. So I'm still going to use the tangent of R, but remember that that's going to be now 5/3. So we hit the inverse tangent of 5/3, and that's going to let R be 59.04. So we've done the work with our trig ratio, so we get 59.04 degrees. And then we still need to find the measure of QR. Well, remember now, we do have a right triangle. So all we have to do now is use our Pythagorean theorem, and we know the two legs. So 3 squared plus 5 squared is going to equal QR squared. And it's 9 plus 25.
Please excuse interruption.
34.
Sophomores and juniors who are taking...
Okay, so 34 is going to equal QR squared. And all we're going to do at this point then is to take the square root of 34. Okay, because that's going to give us QR. And the square root of 34 is 5.83. And since the question asks us to go to the nearest tenth, in this case, because it's not like a plane flying and we're going to run into a building, we're going to go ahead and drop it down to 5.8.